Yeah, stop it. Okay, team, we are in the week 7. So we almost know about, I think, we will have 12 to 13 weeks this semester. Because we stopped classes, I think, in 20 of December. I forgot the date. So almost in the 3rd week of December. And assignment 2, I have already published it, and I have already published the grade for assignment 1. So who is here or who is going to listen to the recording? If you have any concern concerning the grade or the feedback, or drop me an email. I'll try my best to reply. And don't forget to send the assignment too. Again, before I start with the lecture, I want to tell you that, or to remind you, that we expected to have 4 assignments. So the first one, second one, we already done with it. Still maybe the deadline for tomorrow for assignment 2. And then we should have another 2 assignments next month in November. So almost each 2 weeks we'll have an assignment. So we'll have 4. And we will have a project. So now I think that you are in a level that you can write a small project from A to Z based on what you have already learned so far. It will not this week. In the first week of November, I will publish different topics. I will not give a brief guideline. However, I will give just the topics, what's needed from this project. And I will break you down to different groups, all the students, not who only joined the live session, all the students. I will double check the number of the students in the class. Maybe you will have between 3 and 5. So maybe 3, 4, 5. I'll have to double check the number of the students. So not more than 5 and not less than 3. So depend how the number of the students in the class. The 40% of the grade of this course is based on the assignment. So each assignment 10%. Who is attending worker group exercise and taking bonus? The last week I didn't add the bonus. I will add it today. So I will add the bonus after we finish all assignment. So then I can see how many bonus I have. So I can see what is the all bonus you get it and put it in the assignment grade. Also, I will add bonus question to all assignment to be fair with the people who can't attend the live session. So still who can't attend the live session, they have an opportunity for bonus grade within the assignment itself. So for assignment, then we will have a 40% of the total grade. The project will be 30%. I will send also guidelines for the project. The project deadline will be the end of the semester. So I think that the last live session we can use a project presentation who can join us, and who can join the live presentation is going not just to send me the code, also has to present the code. So I will announce this, that the project delivery will be the last week in the semester. Plus there is a presentation needed. So either you will attend the last live session, which would be we can use it for project presentation. And if you can, you and other partners of the project, you can make a team meet, and then you are going can the same what I do. You record your presentation and share with me the link for the presentation to double check the presentation. Why I'm asking to have a presentation? From the beginning, I said I try my best to be your coach more than an instructor. So I believe in students, especially now in the 100 courses, which means that should be expected first year or third semester. Students, they should practice how they present their outcome, because many students, they sometimes know how they can solve their own problem, but they don't know how to present themselves or their outcome in a good way. And to be honest, this is very important to you especially later to your career, that this scientific outcome, you should know how you can present it. So I will give a portion from the grade of the project based on the presentation skill, which means that how you present your work, the clarity of the presentation, your body language during the presentation, which means that if anyone has going to see your video, really can understand what you are saying. So it will be a good practice for you. So a portion from the project grade will be based on the presentation that you are going to do it. So take care for this. Be creative. How you are going to present the project work in a very clarity way and a very impressive way that me as an audience will let me somehow excited about your presentation, and for sure I will give you a nice grade based on this. So this is a project 30%, no midterm in this course, because some students send me an email asking about the midterms because you have midterm now. So there is no midterm in this course. 40%, as I publish in the syllabus, 40% will be assignments, 30% will be projects. So 70% assignment and project. Imagine it. 70% for a work you do it at home, having a plenty of time. So assignment, you will have about 1 week for this. Project, if I publish it, you will have about 5 to 6 weeks to do it. So I expect all of you have a nice grade if really you are responsible, you are working and giving effort on this course. And we still have 30% in for the final, because this is asynchronous online courses. So the final will be also online, but it has a specific time slot. I will double check if the administration will announce that final time, or I have to announce it based in the email I received from the administration. However, when I have already managed the final for this course, I choose to have a specific time slot, because you have already 70% of the grade, you have plenty of time. So the final, this 30% will be for the people that really have already practiced this course. And the final will be somehow similar to the assignment. So you'll have piece of code to write it. Maybe you'll have a multiple choice and true false about the conceptual exercises. And you will have different code you will ask to add this code within the final exam. So this is all about the course administration and grading. So if anyone still have any question from the audience today, go ahead and ask me. No question, like always, 3 thumbs up to continue. I need 3 thumbs up to start the lecture. Lisa, 1. I said I need 3 thumbs up to start the lecture. So Viraj, second one. What about the others? Liam, Kirsten. Yeah, go ahead. Okay. The aim from this thumbs up, just to wake you up. Still be awakened here. Okay. Okay, let's start. There's the last point. Sorry if I forgot it. I just sometimes I have to add some notes, because for you and who is going to watch this recorded video, when I upload it to YouTube, I choose the language as an English for this course, so the YouTube will automatically generate a subtitle. So anyone more interested to see the subtitle, just he has to activate the button, because some students send me an emails that asking that why didn't add subtitles. It is an automatic one. I don't want to add it while recording, because sometimes maybe some people don't want subtitles to be in the screen. Maybe some student need it or prefer to have it. So in this case, just you have to activate this in the YouTube. The last time we talked about structure, and we have already discussed concerning what is structure. I think there is another course about data structures, maybe next semester. You can register these courses. We will talk more about different kind of data structure. Today, just I want to base on the C++ struct that we have already defined it before, which is talks about a data structure. I'm talking about C++ structure or struct. Based on what we have already discussed, that it is a data storage or a data structure that contain different variables as a one package. So you can have, for example, it can have 3 different variables and with different types. This is what struct. You can have a struct X that have an integer A, it have a double B, and it can have a char C in this case. So groups of variables can be assigned as a one group within a struct. So struct is a group of variables in this case. And we said that this struct, we can create different instances from this, and each instance will have these 3 variables based on what we have defined this struct. Today, we will use struct that we have already discussed the last time to create a new data type, or sorry, data structure, not data type, data structure, that will be more flexible comparing to, for example, to the array, because again, array that we have already, as a beginning, talked about it, array, it is set of members of variable assigned within the same object. For example, you can create an array with 10 items, 15 items, 25 items. But the main disadvantage from the first type, from the first date we talk about it, it is that the first one disadvantage that all the members should have the same type. I can't create an array that have integer, float, and string at the same time. Plus, I should have a predefined number of elements when I have to create this array. Today, using struct, we can create chain of elements, and we can insert and delete different elements while we are running our code. So if you are creating a program that need to store temporary in a data structure, and you don't know what is the length of the structure, because even though you are going to use vectors that we use for the string, but however we said the vectors that each time we reinitialize the vectors, maybe it will be memory consume. It will consume huge portions of the memory. This is why we said we should have an upper capacity in order each time not to reinitialize or redeclare this variable. Today, using the struct, we will create, here's this point, this word, that we will create a chain of elements, and then we can add and delete this element based on what is needed during our running our program, whatever it is a program about. So, as I said, the struct, the linked list, it will be, so it can grow and shrink. So growing and shrink means that you can add different chain, like train. And as if the same concept like train. So you can add many pieces of the trains, and you can, based on how the amount of products or goods or whatever it is you are going to use this train to transfer them, or to ship using the train, so you can add different pieces of the train. The same here. So we will have a node. This is, we name it, sorry. We will have different nodes. So we will use 2 concepts that we have already learned, struct. So each node for us, it is an instance for a predefined struct, which means that it can have more than one variable. Like here, it has two variables. And we have to use the concept of the pointers. So each node in this case, we will have a data that we hold it in this element. It can whatever, integer, string, whatever it is, the data you want to put it in this node. Plus a pointer that point to the next link. We said they are chain. So having them as a chain, each node will point to another one to stay in the chain. So a node, it is a struct that can have more than element. Minimum, we can have two elements in this case. That one element holding the data, whatever is the data that, and another one holding a pointer using to next link, to next item. So we use the two concepts, struct and pointer in this case. The head is somehow is a pointer to the first node. So this chain, because we have different element. Each element is a struct that has one element for the data and one other element that point to another node. So as I said here, nodes contain data items. I said data item or items. You are going to define your own linked list based on struct. So based on what struct you are going to use it, you will go ahead and do it. So maybe you define that it will have 4 or 5 items. It depends on what you need based on your program. And a pointer that point to another node at the same times. So, and we should have a pointer that point to the head of this linked list, which means that point to the first node. We need it so much because later, if you are going to search in this chain, whatever it is, because we have different elements and each element struct, so they are saved in the memory. So if you are going to search between of them, we have to start with the head, and then we go and search whatever different data item you are searching for. So a head, it is just a pointer that point to the first node in the chain. Like here, we have 3 elements here. Here, each element or node has, it is a struct that here had a variable can be saved here, and also have here we have 2 data points, for example, and maybe we will have also another one pointing to the next linked list. And we have a head as a pointer pointing to the first node in this case. So the head will point to the first node, and each node has a pointer that will point to the next node in this chain that we name it linked lists. So implementing this node, so we have first to see that what is the struct that we are going to use it. For example, here, I use item, count, and a pointer. Because now each node, for example, at here, I will create a node pointer that point to an instance from here, which means that we said that we can create a pointer and then it refer to another variable. Here it will refer to an instance from this struct. An instance from this struct, it is what? It is a node. So I said here, I define a type. We said we used it before in this type define. So whenever I create a list node pointer, it will be a pointer that point to an instance from this struct. So it will have 3 elements. One element is a pointer that we will use it to point to the next node in this case. Okay. This head we have already talked about it, so it is a pointer that point to the first node in the chain. It is a must to have a head. or then this chain, if you don't define to add it, you will lost it. So how you can, because you have different nodes and each node they are linked to each other. So if I want to search for, it's not like a predefined array. You, for example, set integer array x10. So whenever you are going to access any element in the array, just you go x0, x2, because you can point to this object that has whole 10 items. However, here we have each one, it is an object or it is a struct that is totally independent struct. However, it has a pointer to the next one. Don't see the linked list as if it is a built-in data structure. No, we are building it. It is different struct instances. Each one, it has a struct. It is totally independent. However, each one has a link to the next one. So this is why they make a chain. So we should have a pointer that point to the first item, or we can't deal with it because we can't know where it is in the memory now. There is no one variable that point to the whole of the linked list. Again, when we said we declare an array, we name it x, has 10 elements. So using this x variable, we can point to this array. Here, no. We have just a struct and then we have pointer between of them. So I need, in order to deal with this chain, I should have pointer to one of them, which in this case, the header, the first node in this chain. And now, if you want to access any node, so we can start with the head. We will see now how we can do it. And when we have a pointer that point to this struct, as you know about pointer, so we can set count, item, whatever it is. Okay, let's start if we are going to build it from scratch. So first I have to define what is the struct I needed. I name it node. You can name it X, Y, Z. Just I name it node. It has two elements. First one, data. What I want to save only one data element. You can create different elements. So I said it is not a predefined type. We are using struct and pointer. We are creating this chain. So each one of you can create the chain based on his needs and based on the application you are dealing with. So struct node will have integer data, and we have another pointer, node link. So this pointer that point to another struct from the same type, we will use it later to point to the next element in this chain. And we defined a type, a pointer, not each time to set it is node. So we node plus, or this node plus, which means that in this case, it create a pointer to a new instance from this. And we have to create also a special pointer, we name it head, that we are going to use it later to point to the first node. So if we create a pointer, this pointer, based on what we have already discussed, creating a pointer, it should refer to a variable or to a dynamic variable. So if I have integer x, this is a variable. So, and then I create a pointer, for example, y. This should be referred to what? In this case, y should refer to and y should refer to x in this case. This is type this is type diff. I said this is before. It is just a shorthand. What do you mean by shorthand? Then rather than each time I said, okay, this is just, I said not PR here because I use it the same. For example, suppose that we'll have another name. I can type diff n, I name it n star, which means that this is node will be pointing for this node. This pointer will pointing for this node. Again, it is just shorthand. So when I said the shorthand, mean that you can still go ahead and said, okay, you have a struct node you have already created, so it is a struct. So you can set it is node star. This is work. This is okay. And sometimes, if we will have a name, we need to have a shorthand for this. That using a shorthand, which means that using a simplest name to the initial variable that we are pointing to it. Here it is the same. It doesn't make any, let's say it doesn't make any sense in this case, because we are using for this node plus for the same name as a struct, but in general it is just kind of a shorthand.
I have a question.
Go ahead.
So go on the slide that you just were.
Sorry?
Can you go to the next slide? Yeah, there. So
Here?
the one before.
Here.
Sorry. Yeah. So the type def node, like the pointer on the bottom, is pointing to the structure that we just defined above, right?
It points to an instance from the structure.
Oh, okay. So it'll just point to any. Okay.
This now node pointer R, which I defined it. Now I can create, for example, you see here, node pointer head, which means in this case head is a pointer from type node pointer, which means that this head is a pointer that can point to an instance from this struct. We name it node.
Okay.
Again, we can rather than using type def here, we can do it as a saying like here, node star head.
And that's the same?
The same, yeah.
Okay.
This is what I said, Kerson. This is what I use the word shorthand, which means that here it doesn't make sense, this example that is in the book. Because normally we do shorthand, for example, there is here a type, type node X, Y, Z is a very big name. And then you said node X, Y, Z, it has N. So I go here, I said it is here. I said N head. So it is a shorthand, just a shorthand for us that the name of the reference that we are referring it, we give it another name in this case.
Okay, that makes sense.
You
Thanks.
got it?
Yeah.
What about Raghav? I'm saying your name in the correct way, Raghav. This is correct, yeah? This is the first point. Are you still here, Raghav? Raghav? Yeah, so I'm saying, what about the name? I'm spelling it in a correct way. Raghav. So just give me thumbs up, one thumbs up. Yes, perfect. Okay, so as I said, it's just a shorthand. So for us, this pointer will point to an instance from this struct. The point that I'm saying now that based on our own, not its own definition, what we have already learned, that a pointer, when we created it from a type, for example, whatever the type of this pointer based on the data type that is going to refer to it. So either this pointer will refer to a special reference. When I said a preference, which means that an existing variable, like I have already typed a variable, an array, for example, or any variable, and then I create a pointer, and then I said this pointer will refer to this variable. And don't forget that J should have the same type in this case. Or it can refer to a dynamic variable. So I create integer x. This is a variable. And then I create a pointer y. I will set star y. I use the and one and x, which means that y point to x. Okay. Or I'll go ahead and define integer y as a pointer. And then I said y equal a new integer. This is we discussed it before. So when I create a pointer, which means that I have already created this pointer and give it a type that will refer to it, like here. I create the pointer, I name it head from this type, so it refers to an instance from this data structure. However, I didn't define to which instance. Either I will create an instance in this case, like here, go and head and create new node, I name it node 1, and then I will set the head refer to node 1, or I will make a new node, and then I said this head refer to this. In this case, we name it dynamic variable. When I said dynamic variable, so it is no name variable. This is, we discussed it in, I think, not the lecture before, the last lecture, the lecture before the last lecture. Okay, like here. So here, I define a type node PTR, which is node plus. So I can just, as I said, I can make this node. I can do node like this, the same. So this head now is a pointer for an instance from struct node. Then I assign it not to an existing node, to a new node that I created that has no name. This is why I said the new node. So either I will create a node. For example, I have already created node 1. I said new node. And then I said head as a pointer will refer to this node 1. So I created the node and give it a name, then refer the pointer to it. Or I will create an instance from this node. It has no name, and I let the pointer do this. And normally we do like this, because the name of the instance doesn't matter for us. We know there is a pointer that points to an instance that we have already created it. No need for the name for this instance, because we have a pointer that points to it. So I create the pointer head. It is not a variable, it is a pointer. And then I said head will refer to a new instance from node, no name instance. So now I create my first node that a pointer will point to it. When we said a node, returning here, a node should have 2 items. So now we can set, whenever we have a pointer that points to this instance has 2 items. What? Data and link. Data and link. So in the first node, I put a data and name it 3. This is a value, data value that I want. The link is another pointer, because based on this definition for the struct, I have 2 items, integer variable or integer items, and a pointer was from type node. So because it is my first node, and I give it a pointer head that point to it, so I don't have another node in the chain to point to it. This is why I said head link equal null so far, because I have only one node. So as if now it is the head and the tail at the same time, because normally when we finish our chain based on how many nodes we will have, the last one in the chain will point for null, because there is no next node to point to it. So we will have a head, and then we will have different node, and the last node will point to a null in this case. We start with the first node, the head, and then the second one in this case, or the next one is null. So far, we have only one node, it is itself the head in this case. Now, we create this node. We name it the head. Okay, I have to create different node now. In assignment 2, I just ask you on assignment 2, one of the question is about create a function. Because based on the group exercise I did it in that we're doing it in class, most of you doesn't use the concept of function. At the beginning of this course, we defined what is a function. We said a function is a procedure set of lines that we give it name. For example, we have integer x, integer y. We said add. For example, we have a simple C++ program. We have integer x. We define it. Integer y. And then we go ahead and said we can create a function add that take x and y and return x plus y, which means that I can call this function. I said add 2, 5, then it will return for me 7. So we should, in our programming, when we start using our code, if we believe that set of piece of code, we can give it a name, and then we create a function. Why we need a function? Because the same procedure here, maybe you are going to use it in different places. So we define the function out of the main method, and then we can call it as much as we want in the main method. Again, don't be confused between declaring a function, which is defining the function what is due, and then calling the function, which is using the function based on what we have already declared. So this is why I like and I motivate you whenever you write a code. Now you are in the first step in your subject and on your degree. So you should always have different function declaration. Here, for example, rather than this piece of code, whenever I want to insert a new node, writing the code again, I can create a function. I name it insert node, and then I call this function whenever I want to create a new node or insert a new node. So let's do it now. So far we have only one node from type struct node. This node, we create a pointer that point to it, and we name it head. And now we are going to insert different node, which means creating different nodes. So to insert this node, I will need, now I create a function, name it insert, get the pointer to the head one, the head of this chain, that so far this chain only contain one node. And the data that you are going to insert in this node, because based on our definition, each node will have 2 items, the data, its integer, and the pointer for the next node. So this is a function that I can create it to name it insert node. So this is the struct that we have already defined. Struct node, it has integer type and a pointer. I type definition node. Again, node, it is the same node star. We have already discussed this. So I can define, this code definition can be done out of the main method. And then we can call this function in the main method as much as we want to create, to insert different node. So I give it a name for this function. I define what is the argument that it take it, and then I am going to declare what this function will do. So I create a temporary pointer. I name it temp. I can name x, y, z. Type not PTR, which means that it is not the star. So this pointer, I create the pointer. Then any pointer, it will be meaningless to use pointer without referring to it to a variable, either a predefined variable that you have already created or a dynamic variable, which means you created this variable and based on a special type without assigning a name. So since I use it a dynamic variable new node, which means I will create a new instance from this struct, and this pointer will refer to this. So now I have the head plus a new instance there is a pointer that point to it, which is this pointer temp. And then I said I have to, now I created this node using new node. And now, and this pointer one, now I have to insert the data that I needed based on this function. Based on the input that I will send to this function, I will put it in the data. And then the link, which is the pointer, I said the link will be for the head so far. And then I said head equal temp pointer. So what's happening now, that you have already the head here. Suppose that you have this. You have already two nodes. This is just an example. And this is the head pointer that point to this one. And you are going to insert a new node. You created it. You put data 12, whatever it is. Here, in order to join this chain, you have to define the link. So what I do this here, the link I said, it is the head, which means that in this case, it is going to point to the head of this chain. So now we have three nodes. This one, so far, it is the head pointer that point to it. And this is a new pointer that points to the new point, the new node that we have already created. Now, according to this arrangement, the new node, the temp pointer node point to it, it should be the head. You remember this? We said when a pointer equal pointer, we said head equal pointer temp pointer. What means this? Means that you will assign to the head pointer the reference of the temp pointer. What is the reference of the temp pointer? The reference of the temp pointer is the new node that we have already created it. So now the head in this case will point to this new node. If you see from the beginning of this course, I said it is sequential course. What is sequential? This is what I'm asking you always, that you have to go and do it weekly based. I use the whole concept of pointers here and use the concept of structure that we have already used it or discussed it before to create this chain. I repeat this because it's very important for all of you to understand it in a clear way, in a very clear way, because I want to be sure that you have already practiced the concept of the pointer and the concept of struct to create this chain, plus the concept of the function. So this function, here I define it, and I can call it many times in the main. I can call 3, 4, 5 times, whatever. So each time I call this function, I create a new node. So what this function do? Create a pointer, and this pointer will point to a new instance that has no name. And then I will insert in this new node the data, and it will refer, or it will, using this link, sorry, it point to the header, like here. Till this line, we are here. So because the header will be the first node, and the first node now, the pointer that point to it is temp pointer, and now the head point to the second node. So now I should let the head pointer, because this head pointer, I have always to use it, to point to the new node, just as simple as I said, head equal temp pointer, which means that head now point to the same reference that temp pointer refer to, in which is the case, the first one, and this is what we will have after calling this function. This is what we have before we call this function, or during calling the first line for this function, and this is after we finish calling this function. So we have a new node now according to this chain within this chain. Are you okay? More question? I need 2 thumbs up to continue. Perfect. Let's continue. So in general, what, for example, that an empty list, which means that there is no list, there is nothing, then the head is point to a null. So if you have a pointer that point to a null, as if it is pointing to an empty list, you have to take care of that. Which means that there has no head and there is no node. So at least we should have one node, and this node, the head will point to it. The head point to nothing, then we have an empty linked list. So if there is a header pointer that you have already declared, and it's supposed during your code that is a pointer to a linked list, and then you find that this pointer point to null, which means that the linked list is an empty linked list in this case. Losing a node. So if you have already created a node, suppose you use the header or another one, and you didn't define the link item, because when we create a node, we have two values that we have to define: the data that this node will hold, and the pointer to next item or next node. If you don't do this here, in this function that we define the data and we define the link that point to the head in this case, as we did here, in order to join the chain. And then we update the head. If you don't declare the link item, that is one of the two items in this node, then you have a lost node. And now, because this node, you created this node, but this node, it is not within the chain. This is, we name it, you are memory leaks, which means that you create a node without having it within the chain. So now you are losing memory because you haven't extended your linked list. You have a linked list, suppose to have two items, and you create a new node. You have three nodes. You can use two of them in the chain, and the new one is not linked to the chain, so it is a lost one. And since it is a lost one, so it is a memory, I said a memory redundancy, which means that it is a redundant memory that you are using, that you are allocating memory space for it without using it in this case. Take care for this. Now, okay, we created this linked list. And after we creating this linked list, so we have already created a function in our file. We named this function insert node, so we can call it as much as we want in the main method, and each time we can add a new node and update the head to this new node. Okay, but I'm not doing a linked list just because I want to have a linked list. However, I need now to go ahead after I insert different data in this linked list, because each node holds a special data. I want to search for a special data, if this exists or not, like the same I do in array. In array, for example, I said, okay, this array, I will make a loop based on the number of the element, and I search for a special value if it exists in the array or not. So how I can search now in this linked list? Again, we are creating this data structure. It is not a predefined one. So we are going to create a function, name search. You can give it what name. It takes two parameters. The head pointer, because again, the head pointer will point to the first node. We don't have a pointer that points to the whole linked list, because the linked list, it is different entities or node. It is not, they have a chain as if they are one group, but it is not like an array, which means that I can have a pointer that points to this array. By the way, even though the pointer of an array will point to the first element in this array, because not the first, or not the first memory address of the first element of this array, because the array in the C++ or when is going, your operating system in the memory is going to have consecutive memory address, which means that there is no space between the memory address. All the element will be consecutive. So whatever, this is something it is in the back end. You can see it as a programmer. But here we need the head for this linked list. So to search for a linked list, we need the head. Plus, what is the target? You are searching to which item? What is the item? What is the data item you are searching for it? And then this function, what is going to return? Boolean, or it will return the pointer to the target node that holds this special element. So far, this is the function for me. That this is a function that for my own definition, that it's going to take two arguments, the head of the linked list plus the target integer that we want to search. And if this target integer is already found in one of the node, I will return a pointer that points to this node where the target element it is. Okay, let's go. So now, in the same file that I create a function is named insert node, I will create a function named search node. This is our node that we are doing it. So I take the head and target. First, I want to be sure that this linked list based on the header, the head that was sent to me when I call this function later, it is not an empty one. So I said, okay, if here equal null, then return null, which means that this linked list is empty. This pointer that you send it in your function, it doesn't point to an empty to a linked list, it points to null. So there is no linked list to search in. Else, we are going to make a loop to go one by one, and then go ahead and see if 6 we can find it or not. Suppose that it is 6 or whatever it is. It is here target. So we will use a while loop, and to stop this loop, we should satisfy two conditions. First one, in order to stop, so it should always keep till so this loop will not stop where data does not equal target. So if I go to the first one, does it the data in this node is equal the target? No, continue. So it will stop when the data equal target and the link is not null. Because if I'm searching in the linked list and then I go to head where the next link, which is the link for the next node, is null, which means that I reach the tail. Because the last element, the tail will, the node or the tail node, we can say it, the last node, it has a link to null because it's the last one. So if I reach this node, which means that I have searched because I start with the head, I search the whole node and the target is not found here. So in this case, it is not found. So I will keep it, I will keep this loop. So far, I didn't reach the last node or the tail node, and I didn't reach that target. So once this loop, it will stop. Either I reach the target, then it stop and will send me the pointer, or I reach the last one, the tail one, so it stopped and said, okay, there is no target. So here equal here link, which means that I will jump from one node to another one because the here is the pointer that I'm using it. So first it points to the first node here, because here will point to the head. And then it will point to, in the head, it will point to the next node. And then we will check, does this node has the data and this one have target? Yes, return here. What is here? The pointer where I am now. Else return null till I stop this loop. So if I am going, for example, take this example. The target is 6. So this is my linked list that I want to search in. I have already created this node using insert node. I have 1, 2, 3, 4. The last one will have a pointer to a null. The head will point to the second one, and the second one will point to the third one, and the third one will point to the fourth one, and the fourth one will point to a null because last one. And now I give here. Here it is a pointer that for a special that has a special data that I want to search for. So first I will let here go ahead and see if we will have it here, the point to the first one. And then we will check what is the data here. No, not. And we will go till we found it, that the data like here. Here data equal target, return here. So here, since here is pointing to this node, it will return the pointer of this node. In this case, I get the pointer to the data where I'm searching for. The function that we have already declared at the beginning, we name it insert head, or what we name it before. Sorry. Yeah, head insert, which means insert a new at the beginning of the one. Suppose now I want to declare another function. This function will insert a new node, however, in a special place after a special element, which means I want to insert a node not from the head. I want to insert a node after the second one to be the third node in this case. So I have to now to create a new function. I name it void insert. Give me the pointer after which node you want to insert, and what is the value that you are going to assign to this node. This is my function. So let's first discuss, before taking an example, discuss the code for this. So again, this is a struct that you are using. This is a pointer for this struct. We define a function, name it insert, and then we will go to do function that insert in this node. Insert node after me integer number. So take 1 pointer where we're going to insert and the value that we want to put it. So first I have to create this new node. I create a pointer from type node, and then this pointer I pointed to it to variable, unnamed struct. I say new node. I insert in this the data, the values that I take it from here from the function. And then now what I said, the link, this node, it link to to the next one. So I said the link, the next node, it is the same where the one that I wanted link before. And this will link to it. Let's take an example to understand it more. So this is my linked list so far before I insert. I want to insert after 3 and before 7. I created the node. How I created it using this line, and then I put the data and put 5 in it. So using so far these 3 lines will do for me this. Now so far I created the node and assign a value. However, the node is not allocated in the not allocated so far in the linked list. So I want to allocate it the node. I need to allocate the node now. What I have to do now is that, okay, let insert this node in the chain, this chain. However, I don't want to insert at the header. I want to insert between 3 and 7. So what I do, that the link of 3 where it point, because after me link it point to 7. I said this 5 will point now to 7, which is what is 7? Where I got a pointer of 7? After me link, this is after me. The link, the pointer of it, I take it and put the same value in the link of 5. And now 3 should point to 5 because 5 now point to 7. So far, both of them point to 7. Because after me, I said temp link point to this, temp link point to 7. So temp link point to 7, and after me is already pointing to 7. However, we have to put the chain in a consecutive way. So now 5 again, 5 point to 7, and the 3 point to 7. So we are going to say, okay, 3 now should point to 5, should not point anymore to 7. This is why I said after me link point to temp pointer, which is the new one. So now we will have 2, 3, 5, 7, 9 in the linked list. If we didn't make that after me link, which means that if we did only this and we didn't all both of them, there is, for example, if we said, okay, this is point to here, and we didn't point 3, so we lose rest of the linked list. So we should the new one point to the one that was pointed by 3 before, and we also have to update. So we should do both of them in order to keep this consecutive element of the node list in this case. Removing a node. This is the last point. If I want to remove a node, what I have to do? I want to move a node from this. So for example, I have this, and I want to delete this one. This is my linked list so far. I want to delete this. What I do first, there is a pointer point to it. I name it discard. First, I will let this point to this. And then I will delete the pointer. This is the main point of the pointer, that I can delete this pointer. By deleting this pointer, so this one, there is no, this unnamed node, it has no pointer pointing to it. So now the point is removed from the linked list, and when I destroy this pointer that point to it, but still if it doesn't destroy the pointer that point to it and then make full destruction to this node, so we get it out of this linked list. However, we need to delete this pointer and make full destruction in order not always, we are always talking about the memory usage because this node occupies a space in the memory. This is what I want to discuss with you about linked list. What I needed from you now. So I create an insert node, insert head, and insert after me function. And I created also search function. I want to create now, based on what I have, a new function to count the number of the node. To the same here, to this node. You have this node, and then as I want to create a new function. You do it. You are going to do it. I don't have the code for this. I want you to help me in my lecture. So I want you to create a function. We name it count, that it will return to me number of node in a special node list. So This function will take only one parameter, the pointer for the head, in this case, like here, the head. So it will return integer. You can name it count list, whatever you can name it. It will take the head and return an integer. The same way how I create insert mode. So the function, you can name it count list if you want. So are you interested to go now to the group work exercise and do it with each other? And I'm sure I will help you on this. Any question before we go to the group work exercise? Any question? So no question? Can we go to the group work exercise? I need 2 thumbs up to go. Person, these are perfect. Cool. Okay. Okay, guys, I will stop sharing and stop recording, and later we can record again because now we will go to rooms.
Sorry, so are we coding by ourselves now? And then we're coming back? Are we coding by ourselves the group challenge, and then are we coming back to show our like results, or? Yeah,
like always, we do this always. Okay. So you will be in a private rooms. We will have 2 rooms, and then you will make internal discussion. You discuss how we create this function. You create this function. You implement it. Okay. And then we will be back to the main room, and then we record again, and we will discuss the outcome of each group in this case.
Okay, how do I join the private room? Is it on the weekly live session link, or?
No, I will do it now.
Oh, okay, sounds good.
I will break down you to 2 rooms, and you will be automatically assigned to this room.
Okay.
Give me just a second. And also I will share with you the lecture in this case. But I need first to get, I will stop recording also. Now, Kirsten, what I want you to know about this, so this closed and I close this, you should also this closed. Now Lisa and the other should be here, and Donnie. So go ahead, Kirsten. Now, please open everything, open the main method. So I said that declaring a method for the others. Kirsten, we all share your screen at this recording, so wait us, Kirsten. Okay. Kirsten, go up to you to record. Go up, yeah. So how we are going, Kirsten? Kirsten, listen.
I'm listening.
Yeah, and stop also. So what I want you to learn the concepts and to share it with the other, that defining a function should be done outside of the main method, as you did now. Okay. Before we correct this. Plus, we said that we have something we named a global variable and local variable. So either if the struct node is a global one, so we can keep it outside the main method. So they can, so as it is now, so it is a global one. Yeah. Now, after we define the global variable and define the method or the function that you want to use, now we can go to the main method and we can create an instance from this global variable, plus create a function, call the function that we have already defined. Okay. So now you said you create a head, a new node based on what you have already defined for up. And then you create another node, you name it body. Yeah? Yeah. So we have 2 nodes now. And then you make a link for the head to body. So yeah. Which means that this head now linked to body. Perfect. So now you have a chain that has 2 nodes, but you didn't insert any number on them. It's okay. So far, it's okay. Now you create a third node. You name it and.
Yeah. Oh, you know what I forgot to do? End link.
No. No. Okay. Where is the end pointer? Where you create the end pointer? I can see it.
The end pointer is right here.
Okay.
Yeah.
Okay.
I was just trying to do it like chronologically.
Now you create a linked list that has a head, a hand, and has a body. And each one will have a pointer for the other one. And the last one has a pointer to null. Perfect. Now you will go to count head. So you are going to call the function that define it in the main method. Sorry, you define it outside the main method. I'll run it now.
Right, okay. Hey, there we go.
Perfect. This is the code that we are searching for.
Look at that.
So, yeah, you know your feeling now when you do something and you start something. Oh, I did something. I did it. This is the main aim from the group work. But Kirsten, are you okay about why your code was not working before and now is working? You understand the concept of creating function and a global variable?
Yeah, I understand why it wasn't now.
And whenever you are going to write any code, first you are going to declare the global variable and the function outside the main method. And then in the main method, you create different instances from this global variable, plus you call a function that you have already defined.
Yeah.
So defining outside the main method, calling will be inside the main method, plus creating different instances of the global variable.
Yeah.
Very nice code. Perfect. What about Donnie and Lisa?
Here, I'll stop sharing my screen.
Donnie, can you hear us? Ayush,
Yes.
you didn't participate today in the group work, Ayush. You were late.
Hello?
Donnie?
Can you hear me?
Yeah, you can hear. Are you done with a group work exercise? Can you share with us what you have already done? You and Lisa?
I try to fill this back, but I don't know how to do it. Oh.
Let's go up. Go up. Oh, okay. So outside the main method, you define your global variable struct node. It has variable, you name it char. And then it has another struct node, yeah, a pointer one. Wait, Donnie, can you discuss with us your code?
So I create a list, a string, a char list, and then use the loop to create the node.
So
create the linked list.
Okay, then you use a loop to create different node. And using the list array that you use it, you assign the values from this list array. Not list array, from this list. Yeah, you name it array. From this, yeah, list array. It's correct like this. Okay, and then you call the method count.
Count.
So, yeah. It's working. You have the output. And then is it running now, the code? Can you run it for us?
Run it again.
Yeah, it has 13. Perfect. So you retain number of So you do it in more complicated way concerning to Kirsten, that you created an array having all values, and then you pick the value from this array, and each value in this array you assign it to a node, and you create this linked list node, and you call a function named count outside of the main method, and you call it, you define it outside the method, and then you call it. Okay, Donnie, thank you. Okay, guys, we are done for today. I hope you enjoy it. Next live session, I will announce this. We will not have a new topic. It will be a more lab session, which is we are going to execute different exercises based on what we have already discussed in different lectures. So who can join us next time? It will be a good opportunity to practice what we have already discussed. Okay, guys? If you don't have any more question to me today, I need 2 thumbs up to leave, or will you stay?
Wait, I have one question.
Go ahead.
Do we get extra marks today or no?
Yeah, you get extra points today.
Okay,
Plus
let's
10.
go. All right, cool.
People said that it is, because I said it is optional one, so I can't give a grade because it is asynchronous course. However, I will give just extra grade, a bonus grade for today work group exercise.
All right, cool. Sounds good.
Yeah. And to be fair, for the people that can't join the online session, I will always have bonus exercises in whole assignment, so they can also get solve the bonus exercise and get also bonus grade. Okay. So Kirsten, give me 1 thumbs up. What about the others? I need more thumbs up to leave. Oh. Okay, enjoy it, guys. See you next week. Yeah.
See ya.
Bye-bye.